so it's really delight of mine to be able to introduce Professor Joseph Chen, who is an expert on Joseph Needham. Professor Chen was born in Nanjing, China. Received his PhD in physical chemistry from Notre Dame, and he did research at Brookhaven, and was elected as a fellow to the APS in 1965. He, in 1966, joined the University of California, San Diego, as professor of physics. And I could go on and on, but in any case, he's been back and forth all over the place and back to San Diego, and joins us today in Providence from there. So it's my pleasure to introduce Professor Joseph Chen.
Thank you. Thank you very much. Excuse me. Forgot some notes, it's fine.
Okay.
Yeah. Thank you.
You have to talk really loud too.
Yeah, thank you very much, particularly Professor Tan and the university asked me to give a talk on the Chinese science tradition and at the Year of China, the Brown Year of China. The title of my talk is on the screen, and it was the new source materials produced during the second half of the 20th century by Joseph Needham and his collaborators. Okay. Through their system research. Oh, okay. This one. Through their systematic research in science that facilitated the change in one's view of the early Chinese work in science and technology. This changing perspective, together with remarkable accumulation of artifacts discovered in recent decades by archaeological explorations of China's past, has promoted a burgeoning interest in the re-examination of early Chinese contribution to science and technology. Joseph Needham is an exceptional scholar who was able to approach the study of the history of science in China from a relatively neutral perspective and substantially free from the imposition of his own culture. He's admired for his scholarship and his effort of going back to the original Chinese source in his research. He has a remarkable capacity of appreciating alternative views and approaches. His work will always be of importance in the history of science for bringing into focus the multicultural roots of science and technology. And the early science tradition in astronomy can be traced back to the oldest book in China called the Sangshu. It is in the first volume of the book, and the first chapter called the Yaodian, where we find the commands of astronomy officers Yi and Ho to pay relevance to the grand celestial heaven, to delineate the regularities of sun, moon, star, and constellation, and to relate the seasons for peoples to observance. And in the next paragraph, when you examine, you find there are several missing characters from the textual analysis and the structural analysis. What it says is it further sent the two Yi astronomers and two Ho into two different directions, to the four cardinal directions. And I like to pay special attention to first one. He ordered Officer Yi Zhong resides in Yangguo and enact the welcome relevance to the rising sun and regulate the work in the east. Then he sent another person to the south, west, and north, respectively, with their respective duties. In the Yaodian, also there's a description of the calendar in which the year is taken to be 66 days, 366 days, and forms a year in which 4 seasons are fixed as a system of intercalated months. Okay, so the year when it's written, it was 366 days, and that was also going to be evidence later on the dating. And further, it has a description on the method of determining seasons. Okay, in this method, that this spring equinox is determined by the combination of the Niao star group, and the summer solstice is by combination of the star group Ho. So does the autumn equinox by star group Xu, and winter solstice by star group Mao. What gives rise to one's interest of this account of determination of season is the alignment of the star group in the 4 cardinal directions. Okay. Due to the gradual westward movement of equinoctial points along the ecliptic, the relationship between the seasons and the star group described in the passage has been changing with the precession. This implies, by tracing back the precession of equinox, one can estimate the time when such a alignment of star groups was observed. This would also provide independent dating of the reign of King Yao. The traditional chronology of Chinese history, King Yao is of the Wudi period and should have been active in the 24th century BC. Gabriel was probably the first scholar who used the precession of equinox to estimate the date of observation, which lies between 2155 and 2796. Biot is the first person who actually did a tracing calculation and determined that the alignment of the star group in the 4 cardinal directions occurred in 2400 BC. Other than some uncertainty arising from the exact equatorial extension of the 4 star groups, there appear to be no escaping these conclusions. This provides certain credibility of traditional accounts of early Chinese history. However, dating of early Chinese history has long been an issue. Its history exhibited a roller coaster past. Okay. In late 19th century, the prestige of Chinese civilization was at its low point. Some historians and sinologists not only deny the Chinese history before the Zhou dynasty, but also claim that Chinese civilization is not indigenous. During this junction, turn of the 20th century, Jiaguwen, Xiaobong inscriptions was discovered and deciphered. The decipherment of Xiaobong inscription identifying all the kings of the Song, names of the Song king in the inscription played an important role in restoring the Song dynasty of the Chinese history. But archaeological expeditions led by Anderson in the first quarter of second year concluded that there is little Neolithic activities in the vast land China, and suggesting that Chinese civilization is not much older than what has been revealed by the Xiaobong inscription of Song dynasty. And also Tado, a Japanese historian, in 1921 claimed that early Chinese astronomy was greatly influenced by Greek astronomy brought on during the Alexandria's expedition. Hishimoto showed that the Biot's date of 2,400 could be reduced to 800. If the hour of observing culmination to be 7 p.m. instead of 6 p.m., the traditional time for making transit observations in ancient China adopted by Biot. And when Joseph Needham began to interested in doing some research on the history of science in China, and the antiquity of the Chinese history was in the midst of uncertainty, so he wrote this view. He said, in view of all we know about ancient Chinese history, it seems very unlikely the data of our texts could refer to a time earlier than 1,500, at the most generous estimate, and therefore Hishimoto's conclusion is perhaps the most attractive. But the possibility remains open that the text is indeed a remnant of a very ancient observational tradition, not Chinese at all, but the Babylonian. Clearly, the doubt in ancient Chinese history raised by the early 20th century historians and archaeologists played an important role in Needham's view on the date and the origin of this observation. Needham's conclusion that Yaodian tradition does not go beyond 1500 BC had profound consequences in his interpretation of early Chinese scientific development in astronomy and acoustic. Soon publication of volume 3 of his Science and Civilization in China, knowledge of history of China has undergone dramatic changes due to discoveries from archaeological exploration in China. And schematic diagram illustrating the distribution and interaction of Neolithic culture prior to the Song dynasty that based on available archaeological data before 1985 is given. Okay. Here on the left is the dating of those, the time scale of these Neolithic cultures, and the bottom is a location in reference to the Yellow River and the Yangtze River. It is seen from the diagram that there exists corresponding to time of King Yao, the Davan culture, and the Longshan cultures in the central and the northeastern plain, and the Liangdu culture along the southeast coast and Qijia culture in the west. These were advanced Neolithic culture, and some of which entered the Chalcolithic phase. Inscriptions in the form of pictograms and ideograms are found on the potteries and other artifacts. Among these inscriptions, there is 4 pottery on the east where has glyphs on the pottery. And the 4 glyphs, one each for the pottery, are early pictures. And in 1978, Shao Wangping suggests that these 4 potteries were probably the ceremonial pottery used by astronomers, officers commissioned to the east. Okay, because the Chinese rhythm is such that enacting the welcome of to the rising sun and for regulating the work of the in the east. Okay, so the first 2 pottery, which has the glyph, are pictograms identified with the image of an axe and a hoe. So they were probably used in relation ceremonial for the work in east and the harvest. And the glyph of the third pottery is an ideogram, which illustrates probably the rising sun just above the mountain range on distant horizon. It had been identified by linguistic as the modern word dan. So this could be a pottery that probably used for enacting the welcome reverence to the rising sun. And the last glyph is most interesting, is a compound grams, which is composed of a rising sun on the top. On the bottom is the frames of fire. So that has been written as the sun above a fire radical, and that is meaning warmth and light. And so that party could be for giving thanks to the warmth and light that enact. Okay. These interpretations are consistent with Bia's conclusion that the data of Yaodian text refers to 2400 BC. It should be noted that based on the evidence found in the Xiaobong inscription, Mo Feishi and Dong Zhuoping determined that the Yingshang astronomers were aware of the length of a year to be approximately 365 and quarter days. So this again showing that the thing is written before the Song Dynasty. It should also be noted that in 1983, Zhao Zhuangyu reinvestigated the calculation did by Hashimoto. Then he found the change in time of observation and location does not affect that much. It only changed to 2200 or 2000 BC back. So which is in contrary to the claims by Hashimoto. And in 1997, Sun Xiaochun and Kirsty Maker, and who is also a physicist, calculate the right ascension of the determinate star for the 4-star group mentioned in Yaodian, and they find at 2400 BC the values fit the 4 cardinal directions the best. So this further confirms Bia's conclusion. Bia actually is a physicist too. He's well known for his work on magnetic field generated by an electric element. His vector equation, deduced from experiment, was named after him as Biot-Savart law in physics. Perhaps the most startling discovery in recent years is the discovery of tortoise bone inscriptions. This is dated to 6 millennia unearthed at the Jiahu. Okay, this discovery suggests the use of tortoise shell as a medium for writing began much earlier than the Song Dynasty. These tortoise shell inscriptions undoubtedly are the earliest writing discovered in Chinese civilization, since they antedate the Song Xiaobong inscriptions by 4,000 years. And in the same site, Jiahu, also you will discover a playable bone flute. And this bone flute has 7 finger holes and 2 holes on open ends. And in addition, there is a small hole on top of the 7th note, blowhole. Okay, and the 7th and 1st blow interval, which is very close to the octave. So this most interesting feature of this is the small hole. It shows that the Neolithic flute maker was attempting to improve the 7 notes, 7 blowholes note. This shows that they had a well-conceived tonal concept, and the flute reveals that the attempt to produce sound in a sequence of 7 discrete notes appear much earlier than previously known. There is no doubt that the Neolithic inhabitants who possessed the knowledge of making multi-note bone flute and used inscription to keep records were rather advanced. These discoveries attest to the fact that the pre-dynastic Chinese history dates back at least 6 millennia BC. The data of Jiahu Neolithic site has recently been re-examined in collaboration with the Brookhaven National Laboratory. A total 20 carbon-14 dates were determined, and they show that they have 3 sub-periods, and the total Neolithic site span 1,300 years. The written tradition of Chinese developing acoustic also traces back to the first book, early book in Sangshu. This time it is in the 2nd chapter of this first volume, called the Sun Dian, the records of King Sun. In there we find the statement on standardization of pitch. Okay. And this statement is of particular interest, for it describes the standardization of pitch on equal footing with that of length and weight. Okay. Thus, pitch perceived by one's sense organ for hearing was regarded as one form of physical units, and which length and weight were the others, perceived by one's sense organs for sight and touch, respectively. The function of pitch is described in these paragraphs on the music art of odes. It says that the odes express thoughts in lyrics, and sound put lyric into singing. Sound is produced to facilitate singing. Pitch is used to harmonize sound. And the 8 tones are provided to enrich harmonies. Yeah. And the function of pitch, as it described here, is consistent with the standardization of pitch described in earlier statement. Since only when sounds are toned to a standard pitch can they be harmonized with each other. Otherwise, it will be dissonant. And the passage also talk about the 8 tones provided to enrich the harmony during performing of arts. Here, the 8 tones refers to 8 distinct tone qualities. Okay. The ancient Chinese used the sound-producing materials to classify tone qualities. So from Zhou we find the 8 tone qualities are listed here. So the metal has distinct metallic sound. An investigation of pitch standardization in antiquity has now become made possible by a number of unearthed fixed-note ancient music instruments, which are well preserved in producing their original sound. After examining 2 sets of such unearthed music instruments, a comparative study would be presented to assess the practice of pitch standardization in the pre-Qing dynasty period. The first set I'd like to talk about is the set of 3 stone chimes of Ying-Sang period. Okay. And this set is particularly interesting because they have pitch names engraved on the stones. And the frequencies of these stone chimes, the fundamental frequencies were measured by the Ethnic Music Research Institute in Beijing. If you analyze these 3 measurements by taking ratios, you find they have a trichord structure. Since between the first 2 has a whole notes, very close to whole notes. Between the second and third, it's very close, a minor third. If you look at the harmonic progression, taking the first one as the fundamental, then you see that it's a whole note and a perfect fourth. So, based on written records, the 5th is a favored interval used by ancients for generating tones in tuning music instrument. So the well-known ancient methods such as spiral 5ths and sanfen senyi up and down method are both constructed using the 5ths. It is of interest to investigate whether the trichord of the Ying-Sang stone chimes were also toned using the 5ths. Okay. So from physics, we know that a Y note, you want to produce a Y note, a 5th, from the note X. You need to shorten the vibrating string of the X note 1/3 of its length. This mathematically can be accomplished just multiply the length by 2/3. So the notes generated, the Y note generated from X would be a perfect 5th respect to X. So by doing that, you subdivide octave into a music scale. So the sanfen senyi method is described here is that you produce X to Y1, you produce a perfect 5th. You can also produce another perfect 5th just by doubling the length. So that means multiply by 2 of that, so that equivalent for X is multiplied by 4 times 3. So you can generate the fix by choose in which octave you want it to lay. Okay, a calculation based on this method is found in the book of Guanzi. The book is attributed to Guanzi, called the Book of Master Guan, but the book was compiled by academicians of the Qixia Academy during the stay of Chu. So it probably comes from the 5th century BC, not the Guanzhong period. Okay, if you analyze the generator pentatonic scale, you find that the Z node is the lowest one, would be the fundamental. You look at their intervals, you find their major second, perfect fourth, perfect fifth, slightly off in the major sixth. Okay. So then you can analyze these three stone chimes here. They have a whole note and a minor third intervals. Then you see this another one of this. So trichord has the function as a tetrachord in a heptatonic scale. Here, two trichord forms a pentatonic scale linked by one whole note. And if you identify this, then the notes can be identified with later terminology, so that the three trichord will sound like sol, la, do. And so the second set I like to talk about is the Marquis bronze set bells. These are also playable and unearthed in 1978. The largest bell weighs 203 kilograms. And now, this set of bells, here is a picture when the tomb was beginning to open. After you take the dirt and stones away, and then a layer of charcoal, then the huge wooden planks appeared. And once you take the plank out, you feel that the entire tomb was saturated with water. This is very fortunate for the bells because they are not salt water. They act as a preserving agent. But it's very bad for all writings on silk and on whatever the mediums or bamboo slit. So we don't have too much written records on this, but the bells are well preserved. Once you drain out the water, you see the bells. Some of them still on the rack. A few has fallen down on the ground. And excuse me. Okay. Among the bells, I forgot to point out one of the bells looks different, and that is a ceremonial belt from King of Chu. In the middle has the engravings, and what it says is in the 56th year of his reign, King of Chu returned from Xi'an and made this ceremonial and ancestral bell for Marquis. It was offered to Marquis for his enjoyment forever. So we have a very precise dating when the tomb was probably closed. So Marquis said the bells, 65 in total, were unearthed together with another 60 pieces of ancient music instrument, including string instruments such as se and qing, wind instruments such as pan pipes and mouth organ, and percussion instruments such as drums and stone chimes and bells. This discovery constitutes the most spectacular example of an orchestral collection of music instruments coming from the 5th century BC. These are the sample of string instruments unearthed from Marquis tombs. And the most interesting one is the top one, which is not a play instrument, it's a tuning instrument. It's too narrow for playing, but that and here is an aerial picture of the first exhibition of Marquis tomb in San Diego at the Museum of Art. And in front of that is a toned replicate of the the toned replicate of the bells. Okay, and then you have the San Diego Symphony Orchestra together, and they made some performance in the opening ceremony of the first exhibition of Marquis tomb treasures. After this exhibition, they went to Smithsonian Museum and had an exhibition there. Okay, the Marquis bells consist of two kinds. One is the new bell, and the other is the young bell. The young bell has a long stem on the top and various decorated. The new bells do not have decorations, but they all have engravings of the note name, pitch name, and also descriptions of this bell's relation to some other bells. Okay, so when this bell is taken out of the tomb, the assignment codes were assigned to the bells. So this will be assigned to T1, the top rank and the first group. Then the second group, so the bell will be so T11, our first bell, and the middle ones was M1, 2, 3. So M11 will be this bell, the first bell, and then this is bottom. So B1 will be this bell, B11 will be this bell, and so they all have code names for the bells. And if you examine the bell, they have a olive-shaped cross sections. So these bells do not have axial symmetry. Instead, they have planary symmetry. They have the two perpendicular planes. And so they divide these bells in two separate regions so that you can produce tones independently. And this is quite imaginative idea at that time. Okay? And the two-tone acoustic property of arm-shaped bells were toned to accommodate chromatic intonations. This was well conserved by three independent frequency measurements. They measured the frequency of the striking notes of the set bells and via a chromatic structure for the music scale covering a range of 5.5 octaves. And holograms of the bells were made from the zhenggu. That means you hit in the front or you hit inside. The two, and you see this a family of overtones and showing that, and they are not interfere with each other. Okay, and also another feature interesting because the cut is so that they have a very sharp edge where they joined. So they are discontinued in the second slope so that the sound dies off much faster than a cylindrical bell. Otherwise, you will have to have a damper when you play the damper, and that is very ingenious of that time to find this way. So the Marquis set bells are unique not only from the chromatic tonal system encased in them, but also their inscriptions. The note names, pitch names, are properly inscribed on each of the set bells. Furthermore, in the middle zheng area, the bells, additional description on tonal variations, mode relations are inscribed. With the well-preserved sound-producing ability, the Marquis set bell acted much like a live music musical document coming directly from the ancients. The inscription provides information on ancient music theories and acoustic principles. When played, these set bells produce not only the original sound of the 5th century BC, but also provide us with their tonal range, pitch standard, and tonality variations. In the Zhou terminological tradition for pitch, the pitch which is standardized, the standard pitch is called Huangzhong pitch. Among these bells, the new bells, there are 3 bells has the Huangzhong name on it, but they are in different octaves, the first, second, and third. And so from this measurement, you can deduce what is the frequency for Huangzhong pitch, and that is 421.3 hertz, and which is amazingly close to the standardization of pitch, 440 hertz, first established in 1939. Before discussing the toning of the chromatic marquee set bells, I would like to first discuss another important discovery from the marquee tune. That is discovery of sky map with complete 28 Xiu star groups. This discovery is of significance to our investigation of early Chinese work on equatorial system for positional astronomy. With this equatorial system is the development of equatorial mounting of astronomical instrument and equatorial coordinate for specifying astronomical observations. So these 2 developments are going to illustrate first by an equatorial mounted emulary known as the Jianyi, simplified emulary. Then at the next slide would do a comparison of the coordinates. Here is the Joseph Chen made this. Actually, this is a replicate of the original Joseph Chen's Jianyi. He made this in 13th century, but unfortunately, the original was melted down by a Jesuit who making a quadrant, which is not in equatorial mounting coordinate, instead is in ecliptic coordinate. The replica is now preserved in Zijingshan Observatory in Nanjing. And here is a comparison of the Chinese coordinate system with the modern coordinate system we use universally. Okay. Here this distance called Chujedu, the distance from the North Pole, and a distance to the nearest star group. Okay. And the modern we have, instead of is the complementary that part, and this is called declination, and then you have the right ascent. This modern way is referred to one reference point. Here it refers to each star groups, and there was 20 star groups. Were each tick on the equatorial belt refers to a star group. Okay, and there's a lot of discussion when this star group was formed, so that we have a equatorial belt of coordinates. And the fact that the North Polar distance is simply the complementary of declination and the and the angle from the determining star of the nearest shield star group is equivalent to right ascension, seem to suggest the two celestial coordinates could probably be related in their development. It is well known that the ancient Greeks as well as medieval European astronomers used the ecliptic and circle of the celestial longitude as their reference circle. Thus, the star position is expressed in terms of ecliptic longitude and latitude. Not until the 16th century did the equatorial system began to emerge as the major celestial coordinate system. Needham has commented that since Renaissance, and especially since the work of Baret, modern astronomy has made universal use of equatorial coordinate system using right ascent and declination. He also commented that many European scholars have found it almost impossible to believe that a full equatorial system of astronomy could have grown up without passing through an ecliptic phase. Yet undoubtedly it happened. Okay, the equatorial belt of the Chinese equatorial coordinate system was marked with 28 star groups. This set of star group originated from the 4th star group we discussed in the beginning. Was used to track the sun's position to identify the equinox and solstice. So they serve conveniently as a reference to specify celestial position in recording celestial objects. Examples of such usage are found among the shellbone inscriptions, long before the set of 28 shield was even completed. Okay. Here is a shellbone inscription. What happens in here? It is the 7th day of here. It comes out a new star. Okay, and it was found within the star group of Ho. Remember that the flames of the Neolithic pottery has this pictogram too. Here now you see in Jiagu, in the shellbone inscription, they are still using that as Ho, the one of the star groups. So 2 centuries of controversy about the antiquity of fully developed system of shield has been set to rest by the discovery of the astronomical diagram of the 5th century, with the name of the 28 shield written clockwise in an oval ring encircling the character Do, denoting the Ursa Major. Okay. Sorry. Yeah. This diagram painted in red was discovered on the wooden chest and was unearthed from marquee set bells. The same tone were the bronze bell discovered above were unearthed. Okay, I just showed the diagrams there. Okay, here in the middle is the names of all 24 star groups. Okay. In the middle is the character though. And on the side there was a dragon and a tiger. And all these writing in seal forms are identified with Han characters in the parentheses. Okay. Other than the homophones and some stroke variations, they are almost identical. And there was the layout of this is particularly interesting. And if you notice below this the circle of the names of the star group, there is one star group here has additional words writing in the spring of certain months. They speculate that is the date when Marquis died, and that this represents Marquis And here there is a Neolithic tomb. Has a person lying this way, and the dragon and tiger. The head is not towards south as the tradition in China. So albeit interpretation of this is part of the four palace. In China, we divide the sky into four palaces in the four directions, which is Behu, Qinglong, and the other is tortoise and the bird. So that is a pictogram of the four palaces, part of them. And in front of the chest and the back, the two other stock palace. But the alignment may be rooted in ancient mythology. Okay, I can't finish on this. Thank you.
Well, I really appreciate Professor Chen, especially the astronomical part. I don't understand as much about the musical part. We have time for a few questions, and then after that, excuse me, at a little bit after 6 o'clock, there'll be a discussion about the book, The Man Who Loved China. And you're welcome to stay for that, especially if you read the book. In any case, at this moment, we have some time for questions.
At the very beginning, you quote a certain book. When was this book written?
That is also a controversy because obviously in ancient times they don't have a book, right? These are coming from the several century BC, and the writings began to standardize in Han Dynasty. So that was the controversy, so they couldn't have the book. But you look at all the writings are very short and structured as you can sing it. Right? So they must engrave it in their memories until a certain time they transfer into writings. So when did the book first appeared is difficult. And they don't have a publication date as we have now. That's clear that but the account is you can deduce from from physics that they seems to date to 2400 BC, the content of it. Yeah, not only the four-star group orientation of it, but also the data of the year coming from the Xiaobong inscriptions.
I have one question. Does Needham refer at all to the 1054 supernova?
Yeah. Needham did refer to this Xiaobong. I mean the Xiaobong particular piece. Yeah, okay. This was discovered fairly early. Because Xiaobong discovered was the turn of the 20th century, and Needham began to his interest is about the second quarter of the 20th century. Yeah. So.
Okay, thank you, everybody. Feel free to have some pizza. Welcome to stay for this next conversation.
Thank you.